What's up, everybody? Hello there to all SAYANISTAS watching this video. To my grade 8 class, welcome to Enhanced Mathematics 8. So this is me, your teacher Lei. Let's proceed. For this quarter 3, week 2, we have this key concepts of axiomatic structure of geometry with these 4 classifications: the undefined terms, defined terms, postulates, and theorems. Now think about it. What is mathematical system all about? So in this whole video, in this whole session, we'll be talking about it. Okay? So the mathematical system helps students learn the essential math lesson of geometric proofs and congruence. These geometric proofs and congruence will be discussed further, okay, in our next in our preceding topics or succeeding topics in Enhanced Mathematics 8. And we will cover its 4 classifications, okay, and concepts of the standard logical system in geometry. It is also the branch of mathematics called geometry as a system, mathematical system. You have your separate subject, geometry, with Mamimay, right? Yes. Yet, in Enhanced Mathematics 8, it is part of the curriculum, the geometry. So, you're too blessed having geometry separate subject, and then another subject discussion for the Enhanced Mathematics. So, you will gain mastery of the lesson fully. Expect that. So it begins with 4 classifications. Again, the undefined terms and defined terms. So last week, in our week 1, you encountered these 2, undefined terms and defined terms. And this week, you expect that we're going to discuss or tackle about the other 2, postulates and theorems. So are you ready? Okay. And these are the building foundation in geometry's logical structure. So what is the difference between postulate and theorem? Here it goes. So what are the examples of postulates and theorems? So these 2 questions, okay, actually 3. So our objectives will be, students, you will learn to differentiate postulate and theorem. Also, illustrate different postulates and theorems. And lastly, you relate postulate and theorem in real life. So let us watch a video.
Hello, class. Alam niyo ba kayo yung trend sa TikTok?
Postulate is a statement that is assumed to be true and accepted without a proof. Theorem is a statement that can be proved to be true.
Always remember, postulate and theorem. Bye.
Once again, so what is postulate and theorem? So again, class, are you ready? This is a TikTok video. Go.
Hello, class. Alam niyo ba kayo yung trend sa TikTok?
Postulate is a statement that is assumed to be true and accepted without a proof. Theorem is a statement that can be proved to be true.
Always remember, postulate and theorem. Bye.
Alright, to sum it up, these 2, postulate and theorem, both statements are true. But the difference between them is that postulate without any proof is accepted as true. Unlike theorem, this statement was accepted because of its proof. You need to prove it first. So we have all postulates and theorems. So let's proceed. So what are the importance of postulates and theorem, by the way? So postulates and theorems are the building blocks, again, for proof and deduction in any mathematical system such as geometry, algebra, or trigonometry. By using postulates, to prove theorems, which can then prove further theorems. Okay, mathematicians have built entire systems of mathematics. So this is a big system, right, students? Postulates and theorems are extremely useful in mathematical applications. We can use them to prove other theorems, and we can also use them in real-world applications. Obviously, these concepts are definitely worth tucking into your mathematical toolboxes for future use. Future engineers, future pilots, future doctors, whatever profession that you're going to when you're in college, you need this in your toolboxes. Okay, class? These theorems and postulates, especially the logical reasoning. But before we proceed, class, I have this prepared quiz is links. So for calcium and magnesium and selenium and sodium, you will be sharing. I prepared two links different. So the content of this quiz is a quiz regarding last week topic, okay? The undefined and the defined terms. So I hope you enjoy this quiz is. I will be sharing the link here in the screen. Also, I will send it in our Google Classroom and in our group chat, okay? In Facebook Messenger. So I hope you enjoy this. By the way, for your information, you need motivation for sure. So top 3 scorers in each section. Take note, per section, there are 3 top scorers and we'll get 2 additional performance points. Okay? Enjoy your quiz review. Let's proceed. Another is, this time we're going to play a game. So here's my instruction. The teacher will present 10 statements and you students will guess whether the statement is a postulate or a theorem. Does this statement needs proof or not? Yun lang yung kailangan yung gawin. Students will be asked to send their answers through Facebook Messenger personal message. You send PM to me, okay, your 10 guesses. Postulate, theorem, like that. Students will be able to submit 10 correct answers. Who will be able, okay, to submit 10 correct answers will get 2 additional performance points. Okay, another 2 performance points. Again, only those students who will get 10 correct answers. Okay, let's proceed. Continue. So, postulate or theorem. So, guess. Number 1. Is all right angles are congruent a postulate or a theorem? So, just guess. Number 2. Line intersection theorem. Okay, there's a clue. 2 different lines intersect in at most 1 point. Number 3. A circle can be drawn in with a circle with a center and any radius. Number 4. Complementary angles sum to 90 degrees. Number 5, a line segment can be extended indefinitely along a line. Number 6, vertical angles are congruent. 7, through 3 non-collinear points, there is exactly one plane. 8, Pythagorean theorem, a squared, that's a squared plus b squared equals c squared if c is the hypotenuse. Distance assumption, on a number line, there is a unique distance between 2 points. Number 10. The points along a perpendicular bisector are equidistant from the endpoints of the segment it bisects. So all these 10 statements can be postulate or theorem. So make a good guess, class. You will get 2 additional performance points. Okay, now class, for the postulates. Postulates are statements that are assumed to be true without proof. Okay, always remember that. Postulates serve 2 purposes. What are those? Number 1, to explain undefined terms. So we need these postulates to explain the undefined terms. So later on, I will elaborate. Number 2, to serve as a starting point for proving other statements. So we need postulates to prove the theorems. So theorem needs postulates. Is dependent to postulate. Okay? Unlike postulate, without theorem, he is accepted. Now, look at this diagram. We have the mathematical system, and this mathematical system classified into 4. We have undefined terms, defined terms, axioms. Axioms, another term for postulate. Okay, a statement which is accepted as true without proof. So these statements can be used as reasons in proving some mathematical statements, like theorems. Again, theorem is a statement that can be proven. Okay, so this is the mathematical system we're talking about. So let's proceed with the examples. So in undefined terms, we have the point, line, plane. Defined terms, in point, we have collinear points, coplanar points, and then we have subsets of a line as defined terms as well. In axioms and postulates, we have axioms and postulates, they're the same, and theorems. For example, in undefined terms, we have the line, point, and plane. Here's the line. And then, for the defined terms, we have the line segment. It is part of the line with 2 endpoints. Okay? And then axioms, based from the undefined terms, we have this postulate. This is accepted like 2 points determine a line. If there are 2 points, meaning if we connect that 2 points, we can determine a line. Okay? And a line is a set of all points, okay, that extends in both directions. And then for the theorems class, this statement can be proven that the shortest segment from a point not on a line to the line is the perpendicular segment. So these are just examples. So let's proceed. So for this part 2, we're going to discuss the postulate 1, 2, 3, 4, 5, 6, and theorems 1 to 3. You know, class, there are too many postulates and theorems. But this time, we're just going to discuss this 9. Okay? Clear? And then I will show you some postulates wherein you will experience or encounter in your next grade, grade 9, then grade 10. Also, nung grade 7, you have this previously. Maybe you just forget it, but yeah, you already experienced some of the postulates and theorems as part of the mathematical system. Let's proceed. Postulate number 1. Remember, a line contains at least 2 points. So, looking at the illustration, take note, you need to master the illustration, how to illustrate a line. This is a line with 2 arrowheads. Okay, arrowheads. Meaning, this set of infinite points extends infinitely in both directions, to the left or right. If it is vertical, then upward and then downward. It never ends. Okay? So, meaning if you have these 2 points, point A and point B, at least 2 points, it will determine that there is a line. Okay? So, how are we going to name this line? Line H. Take note. Line H. Small cursive letter to name a line. Another is, it contains points A and B. So, aside from naming it as line H, we can also name it as line AB. Again, line AB. Okay. Or, the reverse, line BA. That can be. Clear? Let's proceed with postulate number 2. A statement that is accepted, a plane contains at least 3 non-collinear points. Review, what is 3 non-collinear points again? When we say non-collinear, they are not lying on the same line. So as you can see, we have here A, B, C, and they are not lying on the same line. There's no line at all, but they are all lying on the same plane. Okay? What is a plane again? It is a surface, okay, 2-dimensional, where it extends in all directions. In line, it only extends in both directions, left and right, up, down. Okay? How about a plane? In all directions. Okay, and then through points A, B, C, there is exactly one plane. Plane D. How do we name a plane? Sa line I, small cursive letter. This one, for the plane, capital cursive letter. Plane D. Here it is. And then, plane D contains at least 3 non-collinear points. That's a must. We need at least 3 non-collinear points to name it as a plane. Aside from naming it as capital cursive P, we can also name it as plane A, B, C. Again, plane A, B, C. Okay. Let's continue. Postulate number 3. Through any 2 points, there is exactly one line. Again, through any 2 points, there is exactly one line. Can we still draw another line with these 2 points? If I draw another line, can I draw like this? Going up, going down? Is that one line? No. Okay, when we say line, it extends in both direction. Okay, so we cannot have this turn. You turn right, you go up, slant, and then go down. No, you can't do that. Line is just a straight line, diagonal, left to right, going down. You have vertical line, and then horizontal line. So, there's only one line in every 2 points. Okay? That's postulate number 3. And this is the illustration. Always remember the illustration. Next, through any 3 non-collinear points, there is exactly one plane. So, the same. So, we have one plane as long as there are 3 non-collinear points. Okay? Proceed. Next, postulate number 5. If 2 points lie in the plane, then the line joining them lies in the plane. Imagine these 2 points, point A and point B, lying on this plane. Of course, this line joining these 2 points also lie, right, or lies on the plane. That's correct. And this is what this postulate number 5 is stating. That line AB, this is how we write in symbols line AB. Okay, we have the line symbol above the letters A and B. Line AB, how do we read this? Line AB lies in plane C. That's postulate 5. Next, postulate 6. If 2 planes intersect, then their intersection is a line. Did you get this illustration, class? Imagine 2 papers. Okay, let's say I have here 2 papers. Am I gonna tear it off? Okay, so let's have some sample. I have here a piece of paper, and then I will cut it off. I will cut it into 2. No, I will not use this. This one. I will cut this into 2. You know, from week 1, that this represents a plane, a paper, a flat surface. This represents a plane. Now I have 2 planes here, and then showing in the illustration how will they intersect. Okay, I will make them intersect. Another intersection here. Okay, now let us, what did I do? Okay, so we have here look, these two planes intersect like that. What's in the Now, what we are talking here is that when they intersect, their intersection is a line. Okay? Where do they meet? Here. They meet here. And this is a line. Do you agree that this is a line? Their intersection. Do you agree? Yes. Okay, this is the line. The line of intersection of two planes. How about if two lines intersect? What do we call that? A point. Okay, very good. Let's continue. So that is postulate number 6. Now let us proceed with postulate number 7. No. Let's proceed with theorems. Now for the theorem 1, 2, and 3, we have this. We're talking about lines and points and planes again. Number 1, theorem number 1. If two lines intersect, then they intersect in exactly one point. Here it is. This is a theorem that we need to prove. Let's say we have point E. Point E will be the intersection of line AC. We have line AC here. Intersects with line BD. Okay, observe how we illustrate them. And then at point E. So point E is the point of intersection. Do you agree? And there is only one point of intersection. Okay? Wala nang iba. There's no intersection here, there's no intersection here, but only here at point E. Gets? Let's proceed. Theorem number 2. If a point lies outside a line, then exactly one plane contains both the line and the point. Do you agree? Again, if a point lies outside the line, here is the point, point D, and it is lying outside the line AB. So meaning, this plane, there's only one plane that contains both the line and the point. And this, again, these 3 points are non-collinear, right? And these 3 points will determine this plane based on the postulate that we discussed a while ago. So plane C contains line AB and point D. No more. Okay? There's no other plane that contains this line and this point. Let's proceed with theorem number 3. If two lines intersect, then exactly one plane contains both lines. Do you agree? We have these intersecting lines, line A and line B. When they intersect, meaning they are lying on the same plane. So there's only one plane that contains both lines. Imagine, class, again, I will use this paper. I'll be cutting this. Imagine, just imagine. Okay. Okay, I will write lines. Line A and then line B. Imagine these two lines. Can you see it? Yan. Line B and line A. Will they intersect? Is there a chance that these two will intersect? Class, there's no chance that they will intersect. Why? Because they are not lying on the same plane. How about if line A lie on this plane as well? So there you go. They are able to intersect because they are lying on the same plane. Unless they are not lying on the same plane, they will never intersect. They will be called parallel lines. Alright, let's continue. So the intersection of a line A and B contains in plane C. So these are just some of the postulates and theorems that we have. Here are some. Yes, there's more, as it said here. The Euclid's postulates, we have 2 points determine a line segment, part of what we discussed a while ago. A line segment can be extended indefinitely along a line. A circle can be drawn with a center and any radius. Okay? So this will be encountered on your 10th grade when you are in grade 10. All right angles are congruent. This is for grade 8. We will be discussing this also. If two lines are cut by transversal, do you remember this from your 7th grade? I hope so. And then we also have the point line plane postulates. Okay, we have the unique line assumption, dimension assumption, given a plane in a space, number line assumption. There's so many postulates. Okay, and then let's proceed with theorems. We have the line intersection theorem, betweenness theorem. I hope these theorems and postulates that we will not discuss this time will arouse your, the curiosity and the arouse that this engagement that you want to explore and excel in these topics more. So I hope you really have that mindset right now. I really want to learn these theorems. It's just sad that we will not discuss them. But yes, you have all the means, time to study them. You have the YouTube, Google, every search engine, whatever it is, go. Angle pairs. Also, we have these complementary angles in grade 7. Also, here in grade 8, you will encounter them. Supplementary angles. Two angles that are both supplementary to a third angle are congruent. Vertical angles are congruent. All these, okay, are theorems. So, meaning they are already proven. And, of course, as students, you should experience also to prove something. And in our last weeks of third quarter, I guess, you will experience proving. Like, you're going to prove triangles. Here it is, special triangles. Base of angles of isosceles are congruent, etc., etc., etc. There's more to it. Another, we have triangle angles and sides. So, there's so many things to prove, to experience, to explore, and for sure you will all excel once you give your best. Okay, mathematics is a skill that you need to always practice, just like a dance and singing career or skills. You need practice and practice, so you will get a mastery of it. We have these parallel perpendicular lines, grade 9, you will meet them. Now it's your turn. You do learning tasks 4 and 5 of the quarter 3 week 1 and 2 LEAP on your notebook. And you're going to check it using the keto correction added in the exit ticket, okay, which is posted in the Google Classroom. Also, next is, for your performance task, here it is. You will be graded. You are assigned randomly to one postulate or theorem wherein you will make a 1 to 3 minute or minutes TikTok or non-TikTok video, it's up to you, explanation of the assigned postulate or theorem. So, kailangan nyo lang, this will be posted in the Google Classroom. You just need the following, okay, for the criteria of grading. The clear statement of the postulate or theorem that you will be assigned to, that will be equivalent to 5 points. Illustration, okay? Sample, how you are going to illustrate that postulate or theorem, 5 points. Creativity, 5 points. And then presentation, 5 points. And voice clarity, okay, 5 points. For a total of 25 points, okay? Let's do this. And for your collaborative work, this will be posted also in our Google Classroom. You will provide your own version of postulates and theorems in real life, or in what aspect of area of life that the idea of postulate and theorem may be applied. Example, one postulate and one theorem, okay, compiled in Google Slides. So this is collaborative. In one slide, you will all add slide, okay, and then follow the sample template. Example, you have to write your name, section, and date and time. Sa real life natin, you have postulate, sun sets to the west. Do you agree that sun sets to the west? Yes, right? So, we cannot argue with it. We will not argue with it. We will accept this statement as true. That sun sets to the west and sun rises to the east. And a theorem, we have the adding the angles corners of the green board will result to 360 degrees. That's theorem. We need to prove it. We need to measure the angles of corners of a green board before we accept this statement. This is just a sample, so you just need to do and to make your own. Okay? Do you have any question? By the way, I will post another some more samples of real life. For example, people die. That is a postulate. We all know and we accept that we will all die. What else? Number 2 is an even number. That's accepted. That's a fact. Just like a fact. Postulate statement that is accepted. What else? Fish. All fish can swim. Agree? Okay. Just like that. Those are daily encounters that we just accept because it's how about you meet a stranger and you say, I am a Sayanista. Again, you meet a stranger and you say, I am a Sayanista. Do you think that stranger will just accept that? Will just accept your statement that you are a Sayanista without any proof? No. You need to prove it. Where's your ID? Okay? How about you translate it? Because I believe Sayanistas are good in English. Sayanistas are good in science, in math. So they will test your credibility as Sayanista in that way. So it is a theorem, okay? You stating that you are Sayanista is an example of a theorem, meaning it needs proof. You need to prove it before they accept it as a true statement. Okay? Do you get it? Those are just examples. You need to think for yourselves. Okay? And then you add to the Google slide na ma-assign sa inyong klase. So, any question? No more? Or if ever, just send to me a PM of your inquiry and then let me know if I can be of help, what assistance I can offer to you with this week's topic. Now, for your reflection, you will write your personal insights about the lesson using the prompts below. As usual, we have the I understand that, I realize that, and I need to learn more about. Okay, and here's your challenge. You're going to answer the quiz or the written work number 2, because we're on the week 2, via Google Form, posted also in the Google Classroom. No more question again. So talk to me just always. So before we end, I would just like to acknowledge the resources, the Canva for presentation, Walmart Slides, YouTube channel for the screenshots, Quiz Ease, and the Google Slides, and also this Loom that I'm using. Yes, if you need to use some recording app, use Loom app. This is free. And I will leave you with this. One cannot really argue with a mathematical theorem by Stephen Hawking. Why? Because it's already proven. Accepted as true. As long as there's proof. So don't argue with it. You will just lose. Just like, never argue with a 90-degree angle. It's always right. That's all. Goodbye. God bless.